Right, we're going to do part 2 of the build for this project. This is my distribution box for my house battery. We have a 12 volt house battery with a few solar panels out the back. Keeps most of my gadgets running. I'll undo these things for the time being. So what's arrived today are the LEDs to go in here across the fuses. We're still waiting on the continuity beeper, that should be here any day, and my 3 amp 5 volt USB regulator. Although I already have a 5 volt regulator in there, I was going to be an LM7805, however I found I had a 3 amp 5 volt reg kicking around as well, so I'll put that in there. Also arrived have been a box of screws, which we can see here. There's actually 2 boxes. I've decanted them all into the one, courtesy of China. And in this bag here, let's have a shake so we do this one-handed. Here are my nice little bezel LEDs. These are all complete with a rubber ring, that's fancy. And we'll see how they go shortly. But yeah, they should be very nice. And that will be hooked up in series, or no, rather in parallel with the fuse. So when the fuse blows, the current load across it should indicate that the fuse is blown. So rightio, onwards with the project, part 2. Alright, so this is actually take 3 at this clip. A lot of things have gone wrong. One of which I'm a little shaky because my MS is playing up a little bit, particularly the myelitis around the C6 vertebrae. So pretty much everything from my neck down is having some sort of trouble at the moment. But anyway, these are some nice green LEDs here. And these guys are going to go in those little holes. I'm sorry if things are a little windy at the moment. I've got some extraction fans and I've got an air conditioner running just to help keep me a little cooler, because if you're not aware, MS is heat affected, so I'm trying to keep it a little cool. Doesn't work very well when I'm operating a fire tower, and of course I can't show you any of those videos at the moment because my boss has said we are changing our media policy, so I've had to pull a lot of them off, but it said nothing about hidden videos, so I might look at that in the future. Right, so let's get this front panel off and see what we can do. Righto, so I'm going to replace some of these screws too, because I found my last 4 screws that were available in my collection of bits, and they're all just so short. I think there's about 3 turns of the thread that's actually capable of hitting those threaded inserts, which I'll leave a link to my previous video in the description here, so that you can actually see the build for this commencing, if you happen to be coming in from third-party source. These 2 screws here are slightly longer. These are some of the new ones I got from the kit. I'm doing this live, as in there is still 12 volts connected, because I'm running some stuff off the 12 volt circuit and I don't really want to disconnect that right now. In any case, we can see here, as it is in the box, I've actually done a pretty dodgy job of putting the isolation relay in there. This thing here, if we can see, maybe not. Let's move down here. We can see here, this is my 5 volt regulator. Through the very back, up in here, there's an LM7809 for the 9 volts and a little heatsink. The rest of this, well, it looks a little messy, is actually relatively neat. I've got some tape flags here to indicate the in and the out wires from the 7809 regulator there. And these yellow and red are from 5 volt regulator. So what's going to happen now, these LEDs are going to poke through the holes, and I'm simply going to put them across the fuse. So when the fuse blows, they should have some current flow through the LED, not enough to cause any havoc in the circuit, but enough to indicate to me that the fuse is blown, which, when this is a test panel, I think that's going to be a handy feature. So let's get cracking. Now the next thing to check here, and I'm going to take my handy dandy multimeter in diode check is to check the connection between ground and the shield of my soldering iron. Now, that might seem like a silly thing to do, but in the back of this house, there's a UPS connected to the system. My apprentice is checking out stuff too, you can probably hear in the background. Now, that UPS connects my DC ground to mains ground, although it seems to be pretty good. Because the problem might occur that when I go to solder onto one of these fuse holders, I can create a dead short, which could be a little catastrophic for a number of things. So, but it looks like that's not the case. I think I've disconnected the ground loop. It's just an exercise in making sure. It never hurts to be safe for these things, especially when there's a potential for mains. The other thing that's worth noting is some UPS units actually create mains voltage potential across the battery, which a little bit of witchcraftery there, but you can still get a belt off it. It pays to be careful. Alright, so here goes. Now I could trim these cables short, but the problem is with most of my gear it does eventually get repurposed. So I'm going to just tack this on to this terminal here, which you'll probably find is connected to one side of the fuse holder through this little link cable here. Now that is coming from positive, so I'm going to expect that if there is a blown fuse that I should be returning a ground return through the other side of the fuse holder. So that's where we'll tack this one. And this could get tricky with the camera. You may not be able to see this, and probably because I'm doing this in situ, it does make life a little difficult, but we'll do what we can. Alright, well, smell a bit of melting plastic there, which means it's touching the wrong thing. Oh, and that was my thumb. That hurt quite a bit, although having done this for many years, more than 15, I've got used to not flinching. Alright, so that is hooked up there across our fuse holder. So let's test this. I've got our fuse holder out. We'll just adjust the camera angle and try testing. Let's do a quick little test here. Now, the fuse is removed on the 12 volt section. So let's put a small load on this, such as my extraction fans, and we'll move these out of the way. Somewhere out of the way. Let's do this that way, then we can see what's going on. Alright, now if we turn this on, our fuse blown light should illuminate to tell us that we've blown a fuse. There's not enough current passing through that to turn over the fans, and they only require a couple of 100 milliamps each, not a lot of current. So let's put the fuse holder back in and see what happens. There we go. So that's going to work. Time to wire up the next lot. Alright, so I've added all the lights back in and our circuit is active. I need to probably turn on my variable supply at the top. I see what the problem is. I've forgotten to plug in the variable supply. Let's run you there. Okay, so I've put one screw in the top here. Let's see what happens if I pretend that this top fuse is blown. Aha! Fuse blown light does go off. Alright, so we'll do that back up. We know that one works. Let's try this one, because checking these things is important. Right, fuse blown light number 2 works. Alright, let's try fuse blown number 3. And because I'm tapping this off the input side that's running the LEDs, it should be 12 volts. So it doesn't matter what the input voltage is, it should still tell me if the fuse is blown. Alright, so those two are good. Why do I always get push messages at the wrong time? Let's try this one. Alright, there we go. That one's going to work too, and that input side is across the relay, so the relay is still pulling 12 volts. There we go. Ah, something funny here. Aha, let's try this. That's better. I turned it off up the top. So just because something unusual happened, let's just try again. Yep. Righto. So that looks like we're doing well. So the next thing is to use some of my spanking new screw kit and put some screws in. And that's really it for part 2. Part 3 will be how the continuity circuit works, which again will be relatively simple. You see, the two most common things I use on a test bench is voltage and continuity, and the rest of it really doesn't get used all that much. So I think I'm going to continue putting some screws in, and I'll be back when the rest of the parts arrive to show you part 3. So here you go, guys. Thanks for watching. I'll see you in part 3.